So far we have seen many kind of problems what you are going to face in the lack of synchronization. Am I right? What are those? One will be data inconsistency, another one will be data loss, or I can say it as overridden, and another one will be deadlock. Deadlock. To overcome these problems, we are come up with various kind of software solutions. Am I right? Various kind of software solutions. Those software solutions generally classified as with busy waiting solutions. Am I right? In with busy waiting solutions, we discuss lock variable, strict alteration variable, turn variable, all those things we have seen. And there will be another kind of solutions, they are comes under without busy waiting solutions, right? So the reason will be there to come with without busy waiting solution. What will be there? In with busy waiting solutions, the problem is a process is allocated for certain kind of time. If that certain amount of time is continually wasting in busy waiting, then after completion of time it has to come back again. That is one problem what you are going to face in with busy waiting solutions. And one more problem is priority inversion, which I have mentioned earlier, right? So to overcome that, we are moving for without busy waiting solutions. In without busy waiting solutions, also there will be a problem. What is that? There might be number of wake up calls may be wasted, right? There we are using specifically sleep and wake up. When somebody is not sleeping, wake up call will happen, and by the time of actually sleeping and wake up call can't be done. So that's the reason wake up calls are going to be wasted here, right? So that is the reason we are moving for the concept of semaphores, right? And this will be one of the solution, and there will be another solution. That solution will be monitors, right? So in order to work with the lack of synchronization, in order to achieve the synchronization, in order to achieve the efficiency in interpass communication, we can go with this all kind of mechanisms, right? So among those, the last mechanism is monitors. So what are monitors means? Generally we can say it as it is a kind of programming language compiler support type of solution. Compiler support type of solution, right? If you speak technically, monitors are a collection of variables, condition variables, and procedures by importing specific modules. This is what the technical definition of a monitor, right? So you can blindly understood monitors are something like kind of thing which can monitor who has to access the shared resource at a respective time. Earlier concepts what we discussed, we are trying to discuss with respect to same data, shared data only, right? There we are specifically calling, we are trying to control a critical section with help of some concept. Here monitor will control who has to access the critical section, that's it. Monitor is able to monitor who has to access the shared resource, that's it, right? So generally if I say this critical section contains variables, condition variables, and the procedures. Now process P0 want to execute, or process P1 want to execute, process P2 want to execute, or process Pn wants to execute. How many number of processes are going to be executed for the requesting? How many processes are going to be requested for the execution? Only one process will be allowed to enter into the critical section at a time. That will be done using one more concept called monitors. It is at the programming language development, means where developers also can develop it. Right? So, if you look into the syntax, how these monitors are going to write. So there will be a keyword called monitor, which is meant for to define these monitors, and the monitor name, example, followed by a set of variables what you want, and later on condition variables, and it's having the various kind of procedures, procedure P1, procedure P2, and so on. That's it. This is the syntax, right? So that is what the technical definition. It's a collection of variables, condition variables, and the procedures. Procedure 1, procedure 2, and so on. Right? Procedure means what? It's a basic function only. Right? So in Oracle, you will call it as a procedure. Do you know the terminals of all those? SQL, MySQL, they are going to call technical different names. Procedure is a kind of a function which you to solve a particular task, right? The same function what you have written earlier there, that same function I am going to write inside the procedure, right? Then how these procedures are going to work, right? Whatever the code that you have mentioned inside the monitor, how many processes can able to execute at a time? Only one, right? Means even though you are going to have n number of procedures are there, which are used to execute, only one process is going to, only one process allowed to execute. Only one process is allowed to execute. What are the condition variables? Right? Whatever the operations that we are going to perform, all those operations will be executed according to certain kind of condition. Am I right or not? Something like if I say wait is one kind of an operation, signal is one kind of an operation, right? When you are performing some kind of wait operation on a particular variable, means indirectly you are performing down operation for a particular variable. If the down value is less than or equal to 0, less than 0, I am not going to allow to execute further, right? Which means that when the value of this one is less than 0, I will go for making it into the blocking queue. Means when a wait operation is happened, I will make the process into the blocking queue. When a signal operation is going to be happen, I will make the process, I will wake up the process from the blocking queue and allowed to execute, right? And once a process got the chance to execute the monitor, which procedure has to be executed will be defined by again the function name or a procedure name. If I have a chance to execute for the PM process for this monitor, which process it has to be executed, that will be defined by using again a specific thing. PM.P2. What is the meaning of this one? Process M got the chance, that process M trying to execute which procedure? P2. But if you clearly observe here, processor P1 and P2 or processors Pn all are going to access a common data like variables. Variables are going to be accessed. Right? You might get a question here. Are you going to get any data inconsistency? As you are trying to work with variable, are you going to get any data inconsistency? No. What is the reason? Because if I want to access a variable, if the variable is outside of this monitor, that variable can be accessed by many people parallelly. Then definitely data inconsistency will be there. But the variable what I have declared is inside the monitor can be able to access by only one person. That's why there will not be any kind of data inconsistency. Is Is it okay? Fine. So now what I will do now, I will try to explain this monitors concept by taking a real time example, that is again producer consumer problem with monitors, right? So again, what the problem is saying here, producer is going to produce the items into the buffer as up to the buffer is full, right? Parallelly, consumer can able to consume the items until the buffer is empty. Right? That is what the statement of the producer consumer problem, right? But here we are specifically taking the concept of monitors. Earlier cases, what you have seen, producer consumer problem with the data inconsistency code, then producer consumer with busy waiting solutions. Later, the same producer consumer problem without busy waiting solution. Later, the same producer consumer problem with semaphores. Now we are discussing the producer consumer problem with the monitors, right? These are the solutions for the lack of synchronization. To make them synchronize, to make them work parallelly among each other, to get the data consistency, we can use various kind of approaches, right? Among those, the final approach will be producer consumer problem with monitors. Okay, fine. So you can understand this code so that you can get a clear idea. So generally, the code what you are trying to write will be written inside the monitor, right? What is the code that we are going to maintain actually? One will be producer related code, another one will be consumer related code, right? For example, if I say producer related code as is a kind of function or not? Yes, I will make it as enter item is a kind of procedure. Right? While entering the item, what you have to do? We have to check for whether count double equal to n or not. If count double equal to n, what will do? We'll go for sleeping. I will go for weight of full. And then if it is allowed, I will enter item. Then so I had to go with the increment in the number of items in the buffer, count equal to count plus 1. If my count value is 1, what you have to do? You have to wake up the consumer. That's why I am going to give signal to empty. This is the code which is related to the producer. And if you go with the consumer is going to remove the items, right? So I am just general writing, which can be like remove the item. If count double equal to 0, what I will do generally, I will go for sleep. That I will technically call here as weight of empty, and then I will perform remove item operation, count equal to count minus 1. What is the last statement? Count double equal to 0 or n minus 1. After reaching the end of the buffer, I have to wake up the producer. Please try to produce more items. Count double equal to n minus 1. I will go for signal of full. Right? Now, for this, what is the common variable? You have to note down the common variable count. Like how many number of items are there present in the buffer? 0. Okay, fine. And you have to mention the condition variables, right? What are the condition variables? Condition variable will be one will be empty, another one will be full. This is a monitor. So for this monitor, you have to give some naming. So let me call it as producer consumer. No need. If you want, you can give. Right? So generally, you can go with the condition as empty and full. And now to execute this monitor, I will write separate procedures again. That procedure is related to producer. I am going to char item producer and while of 1. So what I have to do? I have to call producer consumer dot. What is the procedure it has to call? Enter item. Similarly, procedure consumer char item C while of 1 producer consumer dot. What is that? Remove item. Right? This is the code for how we are going to work with the producer consumer problem with respect to monitors. Is it okay? Now, generally, if I am the producer trying to produce the items, right? We might discuss here various kind of cases. One will be buffer full, another will be buffer empty, right? So hope you might understood directly. And another case will be buffer is on some kind of, I can say them as some buffer contains some kind of items. When the buffer is full means what? When the entire buffer size is full, like I cannot able to, producer can't able to produce items, but consumer can able to produce. Buffer empty means what? Producer can able to produce items, consumer can't able to do it. Buffer contains certain items means what? Producer can able to produce, consumer can able to consume the items, right? So this code, make it analyze it so that you can get the clear idea.